Hello class. Today we're on lesson number 4 in chapter 9 and we're going to be multiplying polynomials, and we start reading on page 412. In the 19th century, a book titled Marmaduke Multiply was used in many elementary schools to help children learn the multiplication table. The book illustrated each multiplication fact with a picture and a rhyme, beginning with 2 times 1 and ending with 12 times 12. Even today, most people do not learn the multiplication table beyond this point. To find the product of numbers of which one or both of the numbers is larger than 12, we learn the method illustrated here. And what we do is we multiply 53 times 27, and we start with 7 times 3, then 7 times 5, and we'll have 371 there. And then, well, actually we would have had 7 times 3 is 21, carry the 2, and 7 times 5 would be 35, plus 2 would be 37, so we'd have 371 on the first line. And then we'd move down and we would make sure we would line up underneath the 2, and 2 times 3 would be 6. So you see the 6 goes under the 7. And then we'd have 2 times 5 would be 10. So that'd give us 106. And then we would add them up according to each column there, and we'd have 1,431. So in multiplying 53 times 27, we are, in effect, multiplying the sums of 50 plus 3 and 20 plus 7. Okay, and you say, well, how do we do that? Well, let's take a look here. So we had 53 and we had 27. Okay, now they say that we're multiplying the sums of 50 plus 3 and 20 plus 7. Well, when we're multiplying and we say we multiplied 7 times 3 and we got 21, right? So we put the 1 there and we brought up the 2. Okay, so we were actually multiplying 7 times 3 and we got 21. Okay, but now we're going to multiply the 7 times 5. You say, well, that's not 50. Well, in essence it is, because what we're going to do here is we're going to multiply 7 times 50 and we're going to get 350. Okay, that would be 350. And we would put the the 21 down here. So what are we getting here? Well, we're getting 7 times 3, which, remember, we did 21. We carried the 2, then we multiplied 7 times 3, we got 35, plus we added the 2, which was 37. Okay, but notice where the 37 goes in placing it next to the 1. It's actually 370, is it not? Let me just rewrite that 3 so it's larger. Doesn't look like an exponent. Okay, not that an exponent would go there, but so we have 371, which is similar to what we just did over here. And now let's say we would multiply. Well, we had 50 plus 3, right? Now we're going to do 20 plus 7. You might say, well, how did we do 20 plus 7? Well, we're going to multiply over here. Yeah, 20 plus 7. What we're going to do is we're going to multiply here the 2. Hold 1 second. My pen isn't working properly. Okay, got the pen to work right. Okay, so we have 20 plus 7. Actually, we should put those underneath because we're going to multiply the 3. Let's put the 3 again, and let's put the 50 here, but then we're going to multiply by 20. You might say, well, why are we doing this? Well, this is in essence what we did. We did the first part over here with the 7. Now we're going to do the 20 where we multiplied. Well, we'd have 20 times 3 would be 0 times 3 would be 0, right? And 2 times 3 would be 60. So we have 60 here, and we have here 20 times 50, which is 1,000. Again, if we go back to our old math here and the way we were doing it, we would have 0, 0, and then 2 times 0, and then, I'm sorry, 2 times, yeah, 2 times 0 and 10. Okay, so we would in essence, actually I would have written this if we would have written this the way we would have multiplied. We would have multiplied 2 times 0 here, and then 2 times 5. That would give us the 1,000. Okay, so we have 1,000. So now we would have 1,000 plus the 60. All right, and that would be 1,060. You say, well, where do we do that? Well, we did it over here. 2 times 3 is 6, and 2 times 5 is 10. And you say, well, I don't see 1,060. Well, you're placing it into this column here. And when we add these up, it's, in essence, is really 1,060. Because when we add them, we're adding them according to these columns. So truly what you had there was 1,060. So when we add these up, we're going to get 1, 3, carry the 1. That'll be 4 and 1. And what do we get over here? It's the same. Notice that we're adding 371 up here and 1,060 here. So what we're trying to point out is that we were really adding 3 plus 50 and 20 plus 7. I'm kind of noting these over here and showing you that we really just took those numbers and we multiplied them all. Okay, but these were the numbers that represented our original numbers of 53 and 27. Okay, let me clear up my board here so we can go into this expanded version that they show here on the side. Okay, we've cleared the board. Now, if we look at the short version that we did and the expanded version at the very top at 413, on top of 413, it says, notice the 4 multiplications have been done in this example and that the answer is the sum of the 4 products. So that's basically what we did before. We have 50 plus 3 and 20 plus 7, and these were all the sums that we had. We had 350, we had 21, 1,060, and we just added them all up and we got 1431. Now, because the area of a rectangle is found by multiplying its length and width, the rectangle whose length and width are 50 plus 3 and 20 plus 7 can be used to illustrate what is happening. So if we look to the right here, we see this box here, this rectangle. And I'm going to go ahead and draw one up for us. And this is an excellent method for us to use when we are multiplying, because it's going to give us a better visual understanding of what we're doing. And right now we're using numbers, and numbers are quite simple. We can multiply numbers and we know what the answers are. But when we're using variables, well, we don't really quite have the answer. We just have variables expressing values, unknown values. So when we do this, we have to be able to we're going to think outside the box. I know I shouldn't have said that. We're going to think inside the box, actually, and it helps us to put all of our numbers in order here. And again, this isn't necessarily representative of the area, though. They kind of show you the 1,000 and the 350 being a larger box. It doesn't really matter, but it has the same principle of multiplying length times width. But the fact is that our lengths and widths are actually sums. So we're going to just take a look at this and put our numbers here, and let's see how it works. Okay, so we had 50 up here, and we have 3 here, and then we have 20 and 7. Now this is just a grid, and if we follow the grid, and if we multiply the numbers according to the grid, column and row, we're going to be able to come up with the same sums and just add them all up. So we had 20 times 50, which we know is 1,000. Okay, we have 20 times 3, which is 60, and we have 7 times 50, or 50 times 7, either way, that's 350. And lastly, 3 times 7, which is 21. Okay, so we would add all of this up and we'd have the same answer. Okay, similar to what we did when we were multiplying. It's really what we were doing when we were multiplying, but it just visually looked different. Okay, so each of the 4 multiplications corresponds to finding the area of one of the smaller rectangles in the figure. The answer is the sum of the 4 areas. Now these procedures can be used to multiply polynomials, and we have some examples here. So let's go ahead and just remove, and we can put our first example in here. We have multiply x plus 3 and x plus 4. So we put the x up here, and we put the 4 here. We have x plus 3 and x plus 4. Now it doesn't really matter if the x plus 3 is on the top and the x plus 4 on the side, okay, just as long as you're putting, I would recommend obviously you put them in the order, in the row. And notice that these are addition, okay? If they're subtraction, and we'll have that on our next example, we have to bring that negative in here and introduce it to the term that corresponds to that negative. So we'll discuss that in the next example. So we have x times x, which is x squared, and we have 4 times x, which is 4x, and then we have 3 times x. And you might say, well, hold on, we're going across all the way here, and then we're looking upward. Okay, that's why we got x times 4. Okay, and again, this is just sort of a chart or a grid. You may have heard the term matrix. I mean, there's different words that are kind of used when you line up and put rows and columns, but nonetheless, we have here just this is a very simple form. Now we have x times 3. That would be 3x, and then we have 3 times 4, which would be 12. Okay, so then we would add these together. Now we have these are like terms over here. The 4x and the 3x, we could add those together. So our answer would be x squared plus these two would be 7x plus 12. So if we were to multiply x plus 4 and x plus 3, and we would probably write it something like this, x plus 4 times x plus 3. All right, or it could be the other way, x plus 3 times x plus 4. All right, this would be the answer, equals, and just point it down this way. This is our answer. So, okay, so let's do our next example, and in the next example we're going to have a negative. And the negative, we must be very careful that we represent it properly in this particular diagram. It looks like we need to erase this last part here. Okay, so how would we do that? Well, we have multiplied 2x minus 7. Let's put that over here. 2x minus 7 times 5x plus 1. Okay. So once again, we're going to take, and again, it doesn't matter. Let's put the 2x, and we wouldn't just put 7. We can't let that minus sort of float around, and as I've been teaching you, we really have the positive 2x term here, and this is a negative 7 term. Okay, so that would be negative 7 over here. And then we have positive 5x, so we'll put that up here. And we have positive 1. Okay, so we'll put that over here. Now, you know, I'm not going to write the positives, it's understood, but we must be very careful that we mark our negatives properly, and obviously that's going to impact the answer, and as we'll see here. Now, we're going to multiply 2x times 5x, and we know we multiply the coefficients first. That would be 2 times 5 would be 10. Then x times x would be x squared. Now we have 2x times 1, which would be 2x. Now we have negative 7 times 5x, so it would be negative 7 times 5. That would be negative 35. And then we still have the x, okay? And then we multiply negative 7 times positive 1, and that would give us negative 7. So what do? Well, we're going to add all these together. And we could just go ahead and we could write it all out. 10x squared minus, oh, excuse me, that's a plus 2x minus 35x. We didn't do this in the last one, I just kind of skipped over, but I want to write this one out so you can see. We have all of our terms. We have positive 10x squared, positive 2x, negative 35x, and negative 7. And you can see they're all broken down individually, positives and negatives, okay? So what do we have? Well, we have two like terms here, and if we take positive 2 and negative 35, well, that would be negative 33. Let's go 10x squared minus 33x. Ooh, boy, that was an ugly 3 there. My hand just kept making the nice little curvy. 33x and minus 7. So our answer would be that. So we have a couple more examples. If we turn over to page 414, and I'm going to clear up my board here. Let's go ahead and now we have here multiply 4x and x squared plus 6x minus 5. So in this case, we only have one term on the side, and we have three terms, and we see that they're positives and negatives. So our board, or our little boxes, our rectangle, our little chart would look differently. Let me go ahead and just make that. And it would really just only have three. We have one for each going across, and then just one, because there's only one term. So you might draw something like this. Okay. And we would go ahead and start putting in our numbers. So we have 4x on the side here. And then we would have x squared. We would have positive, that was positive x squared, positive 6x, and then negative 5. So let's go ahead and multiply. Well, we have 4 times 1, which would be 4. The 1's hidden there. And x times x squared is x cubed. Let's move over. We have 4 times 4. That will be 20. 4 times 6 would be 24. And x times x would be x squared. And then we have negative 5. So we have 4 times negative 5 would be negative 20. And x, we just have one x left over there, right? So our answer is quite simple. We would have x cubed plus, let's write it down, 4x cubed rather, plus 24x squared minus 20. Okay, x. So that would be our answer, okay? If we look at example number 4, it's, let's clear up the board. Example number 4 has actually now 6, so you're just getting bigger and bigger. Let's draw our lines in between. It's wonderful using this paint program. Oh, that's not going to give us enough room there. Let's just go ahead and... Okay, so... And let's just do it there. It doesn't really matter how large, as long as they're large enough for you to fit your numbers in there, right? So, what do we have? We have multiply x plus 7 and 2x cubed plus x squared plus 10. So we're going to put the x and the 7 here. Get my pencil. The x and the positive, so it's x plus 7, so it's positive x and positive 7. And then we have, it's just all addition, so this is quite simple. We have 2x cubed, x squared, and 10x. Oh, excuse me, 10. Okay, so now we're noticing that we're missing the first degree term. We have an x cubed, we have an x squared, but there is no x, okay? And as you can see, they're using two methods. They're showing you the box, and they're also showing you how you would multiply them if you're multiplying, which we're not necessarily doing that, because we're using the box, and I really want to lean on the box because the box is going to become much more useful later on when we're trying to factor or we're trying to find the missing term or missing variable. We're trying to go both ways, so it's good to use the box. But let's go ahead and now do our math. We have x times 2x cubed, and that would be 2x to the 4th power. Then we have x times x squared, which would be x cubed. Then we have x times 10 would be 10x. Then we come all the way down and do 7 times 2x cubed, which would be 14x cubed. Then we have 7 times x squared, which would be 7x squared. And lastly, 7 times 10 is 70. So now this is not the answer until we actually write it out. But we should note that we have some like terms. Again, we have the x cubes over here that are like terms that we can add. We know we cannot add, say, x squared and 10x or 70 and 10x. These are all in their simplified form, but we can add these two together, and that's going to allow us to express this as, let's take 2x to the fourth plus, we're going to go in descending power, so we have x cubed, right? So we did this one. You might want to even put a little check next to them. X cubed and 14x cubed, which would be 15x cubed, plus, well, I wouldn't know plus, but I know they're all plus, they're all positive, so I can just go ahead and assume it's plus, but we shouldn't assume until we actually do any math or we look at the exact term to see whether it's positive or negative. Our next would actually be 7x squared, and again, descending powers. Then our next would be, after that, 10x plus 10x. And lastly, we have 70. Okay, so plus 70. So here are all of our terms. We have 2x to the fourth power plus 15x cubed plus 7x squared plus 10x plus 70. So you can just go along and do your problems accordingly. Particularly when you do the math, and let's say in your review you'll have like multiply is indicated. I'm just looking at set number 2 on page 415. You can try to do it the same method that we've used in the past in terms of multiplying. I would prefer that you use the box because I want you to get very accustomed, familiar with this, so that when we start factoring, you'll be able to identify not only how you place the terms on the outside, but ultimately we're going to give you the terms on the inside, and you're going to have to sort of do it reverse. Okay, you have to factor it out. So get comfortable, get familiar with these boxes. Okay.